So let's talk about simulation system and languages. And what is a simulation system? Basically, so simulation system is a platform, right, that allow users to build, simulate, and analyze models of complex systems, right? There are purposes of simulation systems. The first purpose is so that you can analyze your system, analyze your simulation, you can test them out, and you can make important decisions based on those simulations. The kind of some features of simulation systems, they have model libraries, right? Pre-built components or templates for common systems, like for queuing systems or mechanical systems that user can modify, right? So these softwares usually work, the engineers work with them to kind of simulate the behavior of the systems. We have visualization tools which are already installed into the simulation systems to understand things that could be flowcharts or animations, etc. We have experimentation capabilities that you can, change the parameters and run different scenarios to see how your system will respond. We have statistical analysis that you can choose for analyzing open data. You can search for mean, standard deviation, these kind of statistical terms. You can find them from these systems, right? There are types of simulation systems as they were type of the systems themselves. They were the types of the models themselves. That's where there are also the simulation platforms or the types of the simulation platforms that you can use to simulate the system you want to. So discrete event simulation system, of course, focus on the discrete systems, right? Like manufacturing lines or queuing systems. The platforms are arena and sim events. Continuous effects on where changes occur continuously, or they work on the continuous systems. And there is Simulink and AnyLogic. And in the agent based, we have, the agent based, the model systems that consist of individual agents like people, animals, and vehicles with autonomous behaviors and directions. NetLogo and AnyLogic can be used for continuous, and it can also be used for the agent-based systems. Then dynamic simulation systems, so focus on feedback loops and time delays, often used for large-scale, high-level system analysis. So BunSim and I think, and this one is the new one, system dynamic simulation systems, right? So where you want the dynamical behavior, right? Or where the things can easily change and fastly change, where that's where you want these kind of BunSim or I think. And then we have simulation languages. They provide a formal structure or syntax for describing the system model, its dynamics, and interaction between its components, right? As for like if SQL is for database or code like Python, C++, everything is for Core, Java, etc. That's why we do have domain-specific simulation languages. So Simulink is a graphical simulation language to allow users to model, simulate, and analyze dynamic systems. It is particularly useful for systems that involve continuous signals and time-varying behavior. So you can kind of make a mind map, that you have discrete here system, and then discrete system have discrete models, and then discrete models have discrete simulation systems, and then in the discrete simulation systems we use this language, and continuous we use Simulink, right? So you can make a mind map to kind of remember this whole process. Modelica is a powerful object-oriented language for modeling complex physical systems. It can support multi-domain modeling, means you can have multiple, domains working at the same time. It can handle mechanical, electrical, thermodynamic, and hydraulic systems all in the same framework. Great. Then we have GPSS, means General Purpose Simulation System. It is a language primarily used for discrete event simulation. Talked about the mind map, you can write that we use GPSS for discrete. We use the Simulink for continuous, and Modelica can be used for any of these domains. Right. It's popular for modeling queuing systems and service processes. HDL, AMS, VHSIC, hardware description language, analog, and mixed signal. Used for modeling mixed analog and digital systems, especially in electronics and hardware design. It helps simulate how signals propagate through an electronic circuit. So they're basically for the physical, electronics part. But the big thing is the name here. VHDL, AMS, VHSIC, hardware description language. You can just, remember that this you can use. There's also some hardware description language that you can use, right? We have VHDL and AMS, right? Or VHSIC, hardware description language, analog and mixed signals. These were domain-based languages, right? They were based on some, domain, for what domain they use and what type of models they work with. Then we have some general-purpose languages like Python with SymPy library. It is a general-purpose language, and SymPy is a library that has support for discrete event simulation. Okay, it's really flexible, and most of the time when we're building some apps or web applications, we need some kind of simulation. We use SymPy. Java with AnyLogic. Java combined with AnyLogic allows for a wide range of simulations, including discrete, agent, system. System dynamics, chaining. Okay, it's always about change. Java portability and voice per use make a choice for building custom simulations. C++ with Omnet++ is often used for performance-critical simulations due to its speed and efficiency. It is also a discrete event simulation library for C++. We have Java with AnyLogic and C++ with Omnet++, right? Then key features of a simulation language, it's its time management, built-in mechanisms for managing time. It could be discrete, or it could be continuous. In discrete, it would be always looking for event-driven simulation. In the continuous, it would be looking for differential equations. It could generate the random numbers if we are working with stochastic systems. It should have some state to work with, like functions or constructs that manage the state of a system. Event scheduling, discrete event simulation, a core feature is scheduling and managing events that trigger at specific points in time. Because these are all parts of features of a simulation language, like the time management. Because when you simulate things, you need to really decide things before or beforehand that what is going to happen next. And most of the time we would have a local, we would have a random number generator, we would have a state management, some time management, and also event scheduling, right? Popular simulation system language. So Simulink we talked about is a MATLAB-based means it's a language. It's continuous and hybrid system simulation. Its strength is it's strong in control system design, single processing, signal theory, and mechatronics. It is a visual environment for building block diagrams, right? So block diagrams really help in building the actual simulation. So it's used for continuous, but it can be used for hybrid system simulation. It could be discrete as well. Arena is a discrete event simulation. It is used in operation, research, manufacturing, and logistics. You can just always learn like what are these type for, and then you can give examples yourself if you don't like to read all these ones. AnyLogic is multi-method. Okay, NetLogo is agent-based. It is used for educational purposes, and it is powerful exploring how individual agent behaviors aggregate into the large-scale patterns. When we have OneSim, we talked about these are used for system dynamic simulation. The other one was I think. You can always search them upon a web to see more of them. SymPy is for use for discrete event simulation, right? So Simulink is for continuous, Arena is for discrete, AnyLogic is hybrid, NetLogo is for agent, and OneSim is for system dynamics simulation, and SymPy is for discrete event simulation. Alright, so you can write them down, and of course choosing the right simulation depends upon the system you're using, or complexity, how much complex you need. For the multi-domain systems, you would need like Modelica would be ideal, but if you're just working with discrete or continuous, you should choose this language accordingly. And ease of use, the simulation systems are more friendly and suited for some languages, so you need to really understand that which one is better, because NetLogo really works with agent-based, and then Logic can work with all of the systems. Okay, so we are done with I think the languages. Now widely used modeling systems. Again, we have Simulink and MATLAB based. We have Simulink, and it is built on top of MATLAB and is widely used systems for differential equations and ambient behavior are critical, such as control systems, signal processing, and mechanical systems. So these are all the same thing, but a more descriptive way. We're just going to go over it because we get the idea. So they are also used in the Simulink is used for automotive, aerospace. Aerospace works with like the simulations building and robotics and electronics and then mechatronics, right? The mechanical engineers usually work with this stuff, right? Okay, so we just need to learn about what is a simulate. We don't need to, really learn about all of these things. We can just write them down. We just need to think that it's continuous. It's a graphical language environment. It is built on MATLAB, and it gives a graphical interface. It integrated with MATLAB, which is also a language, and it is extensively used in automotive, aerospace, robotics, electronics, and mechatronics. AnyLogic is a multi-method. It is a versatile simulation tool. It has strengths. It has 2D, 3D visualizations, has libraries, and is used for healthcare, logistics, manufacturing, supply chain, transportation. Right, so you can add all of the models here because it is kind of multi-method. You have logistics, manufacturing, supply chain, and transportation. There we can all simulate that. Arena, which is discrete event, it is one of the popular tools and it is user-friendly. It is ideal for discrete event systems. It is strong support for performance analysis, including bottleneck identification. It's used in supply chain management and customer service. The Arena, yeah. We have NetLogo, which is agent-based. It is widely used for educational purposes and research. It is simple and intuitive. It is used for studying complex systems. It is used in social sciences, ecology, biology, economics, and education. We have Vensim, right? We have system dynamic simulation. It is used for modeling systems that involve feedback loops and time delays, such as economic, environmental, and policy analysis. It is ideal for large-scale, high-level system and policy analysis, environmental management, economics, healthcare, and business strategy. Of course, the business strategy is really important in Vensim. We have Modelica, which is continuous and object-oriented simulation. It just really works with a lot of domains. The arena we talked about wait a minute, yeah. So AnyLogic is multi-method, but the Modelica is multi-domain language, means you can work with various domains, right? Okay. It works with automotive, aerospace, automation, and robotics. It is high-performance simulation language. Right, you can just read them yourself. And then SimPy is a process-based discrete event simulation framework. Okay, it leverages Python simplicity and is quite easy to code. A strong community support and easy integration with other Python libraries like NumPy and Pandas, which is really important for like LLM stuff or other stuff, healthcare, logistics, emissions, and resource management. General-purpose simulation system. It is also a discrete event system, and this is one of the earliest and most widely used languages. It is extensive, it is simplified, it is used in manufacturing, supply chain, and business process, all that. But the earlier ones are basically the building blocks. The more efficient ones are the ones above. Open Modelica is continuous hybrid system simulation. The other Modelica was also continuous, but it was object-oriented simulation. This is hybrid system simulation. It is for complex physical systems, it is multi-domain, it is open source, community-driven, and strong visualization. It also uses energy, automotive, aerospace, and internet. Omnet++, it's discrete event simulation used with C++, it's a C++ library. Okay, and it is used for network simulations, it is providing extensible framework, and then it has a detailed visualization tools. It is used for telecommunication, networking, sensor networks, and distributed systems. So it is basically used for distributed network systems. So we are going to kind of revise all of them. You can revise with me. So Simulink was continuous, means it's a Simulink was basically MATLAB based, and it's basically continuous hybrid system simulation. And the other thing we read about it was that it has very great strengths. It is for use for graphical interface, and it just can be integrated with MATLAB. It is used for automotive, aerospace, manufacturing, electronics, mechatronics, etc. Talked about the AnyLogic is a multi-method. It can work with any model. It's a versatile. It offers 2D, 3D visualization tool, and it works with healthcare, manufacturing, supply chain, and transportation, etc. Arena is basically AnyLogic is all, and Simulink is continuous. Arena is discrete-based event simulation. It just has a user-friendly interface and works with manufacturing, logistics, by chain management, healthcare, etc. Right, and then we have the NetLogo, which is agent-based modeling, right? It works with social sciences, ecology, environmental, studies biology and education. And then we had Venism, which is a system dynamic stuff where we talked about environmental management and towards the feedback loops, business strategies. Then we talked about Modelica, which is continuous and it works with automotive, etc. We talked about SymPy, which is discrete, GPSS, which is also discrete, is general purpose simulation system, and then we have Open Modelica, which is continuous. But the other one was object oriented, it's hybrid system, and it works with energy, etc. HomeNet++ is also discrete when simulation, it works for network, etc. So these are all the languages. In the next video, we're going to really study the important ones, models of queuing systems. Okay.